Thank you for joining. You're welcome. We're about to start. Please let us know where you're streaming from. Let us know where you're streaming from. We're about to start. I'm not seeing you guys' reaction. Please let us know. Let's engage. Let's engage. Let's start. If you're just joining, you're welcome. Okay, Imaji Otana is in Nigeria. In Nigeria, where in Nigeria are you streaming from? Yes, I can see Ayide. Ayide, you were here with us last week. Imaji, you were here with us last week. I can recognize these two names. And yeah, I can see another person. Manoj. Circuit, yeah. Yeah, good evening. Good evening. Yeah, good evening to you guys. Yeah, that feels good. Yo, Felix Abigail, you're welcome. Yes, I know you, Felix Abigail. Cross River John, okay. Please hit the like button. If you're just joining, you're welcome. Hit the like button. If you've not subscribed to our YouTube channel, just hit the subscribe button so that when I come live next time, automatically will receive notification without me sharing link. Okay. All right, so let's start. Let's get started. The time is okay. Yeah, Anambra State, you're welcome. Kogi State, yeah. So that means we are viewing from different parts of the country. Imo State, yeah. Which other state is not represented? Please, if you know you want to represent your state, please drop that down. All right, we want to talk about the fundamentals of AC circuits. Wow, Delta State, you're welcome, Augustine. When we talk about AC circuit, AC itself stands for, oh, by the way, I hope you guys have your writing materials. We have Ondo State here also. Wow, we want to cover the whole night. River State is also here. Beautiful. Oh, you are Indian? Oh, wow, good to have you guys. Good to have. Bayelsa State is also here. Tama, you're welcome. I'm seeing about 13% on the live stream, but only 7 likes. Have you hit the like button? Please consider to hit the like button. Yes, alternative circuit. That's what AC. Some people feel this is air conditioner. This is not air conditioner. It's alternating circuits. Alternating circuits, not alternative. Alternating circuit. We have what we call the DC, and we have what we call the AC. DC is direct current, and AC is alternating current. Who can tell me the difference between direct current and alternating current? Please subscribe to the YouTube channel if you're just joining us, and please hit the like button. We are excited that we have you on our live stream. Make sure to turn on the notification bell so that by the time we come live, you receive notification. Okay, so when we talk about this AC circuit, remember I told us that we are basically going to be focusing on the calculation aspect of this. We're not going to be wasting your time telling you a story. Someone said AC has variation in voltage, DC is steady current. Brilliant. Another person said direct current cannot travel over long distances, while AC can. Wow. Another person said 180 degrees oscillation. Brilliant. Another one said you can use capacitor to change AC to DC. Whoa, that's a huge knowledge. You can see from what they are saying, they have a lot of ideas about AC circuit and DC circuits. And that is brilliant. The fans, God bless you all. And I love that. And then that is why we say, because it is easy for people to go in and then get the fundamentals, the theoretical part of it, then we're going to focus our attention on the calculation aspect of this. Comes with single or three phase. Brilliant. Okay, you're welcome. You're welcome. Yeah, if you want to learn, you're welcome. Please. Thank you. Please be reading the comments. That's why I want you guys to always engage. Those comments you're seeing there, they are very, very useful. They are supposed to be the notes you're supposed to be taking, right? They are very, very useful. Take them seriously. So that's why you don't only focus on what I'm doing, but the comments, please make sure to engage there. Okay, there are 6 cases we're going to be talking about under this AC circuit. We're going to be talking about the purely resistive circuit. We're going to also be talking about the purely inductive circuit, the purely capacitive circuit. Please take these things down because we do not have time to write a lot, but we're going to be solving a lot of stuff. We're still going to be talking about RL circuits. Remember, the first one I said is resistive circuits. The second one I mentioned is inductive circuit. And the third one is a capacitive circuit. The fourth one is the RL circuit. The fourth, that's the fourth. The fifth is the RLC circuit. And the last one is going to be the RLC circuit. These are the 6 cases we're going to be focusing on. Okay, those are the 6 cases. I'm sorry I may not be able to be flowing with all the comments. So if eventually you want me to read yours and I could not be able to read others covers, please make sure to repost what you type. Okay, so for a purely resistive circuit, what we want to I want to give you a lot of formula that will make you dangerous on this particular topic. We've not started talking about the resonance frequency or resonance in AC circuits. We've not also talked about there are a lot of concept, right? But let's just start, because if I start with that, the RMS voltage, RMS current, and the rest of that is going to be huge. So let's just start, right? Okay, so for purely resistive circuit, the current and the voltage are in phase. When we say the current and the voltage are in phase, it means the current is not leading the voltage, neither is the voltage leading the current. So we consider Ohm's law. Who can tell us what Ohm's law is? Please, let's be fast. Remember, this class is an hour class. So let's engage in the comment section. Who can remember the concept Ohm's law? What is Ohm's law? Any idea? Yes, I can see the formula. Somebody is dropping formula. Please verify if that formula is correct. Please, you're joining us, you're welcome. Hit the like button. Hit the like button, everybody. Let's go. Hit the like button. Hit the like button, everybody. If you've not subscribed to the YouTube channel, just hit subscribe and turn on the notification bell. Ohm's law is like my ex-girlfriend. This one is funny. Okay, so the current passing through a metallic conductor is directly proportional to the potential difference, provided temperature and every other physical quantities are constant. Hi, you're welcome. Good to have you. So we have V equal to I arrow, basically. So now we're talking about resistive circuits, which is this particular one. If you make this the subject of the relation, you then have, remember I said the current and the voltage are in phase, you then will have arrow to be equal to V over I. How many of us know what I did here? You can see that the current and the voltage are in phase. How many of us knows what happened here? You're welcome, please. Ohm's law states that the current flowing through a metallic conductor is directly proportional to the potential difference. Brilliant. Brilliant. That is superb. Okay. Okay, for those of you who said, I don't know, if we make this an equation 1, if you want to make arrow the subject of the relation, somebody said you make arrow the subject of the formula. Exactly. If you want to make arrow to stand alone, where you have V equal to I arrow, what you need to do is to divide both sides by I, so that I and I will cancel, leaving us with arrow, which is the arrow you're seeing here, and then V over I is this one you're seeing here. Remember, the unit for resistor is ohms. All right. The unit for this resistor is ohms. The one for this voltage or potential difference is volts, and current is in watts. What is the SI unit of current, everybody? Let's go. Somebody say, please just joining, someone should help me. Types of circuits. We did not mention the types of circuits. We say under the AC circuit, we'll be covering 6 concepts. One, a purely resistive circuit. The second one, a purely inductive circuit. Another one, a purely capacitive. The symbol for inductor is L, capacitive circuit. Is that okay? So also we'll be looking at RL circuit, RLC, RL. This is where we'll be talking about impedance. When we get to these points, 4 to 6, we'll be talking about impedance. So I'll show you the formula for the impedance in RL circuit, the impedance in RLC circuit, impedance in RLC circuit. Okay, making sense? Somebody says amps is the SI unit of. Somebody say watt is power, dude. Please, we are talking about the SI unit of current. Amps, okay, brilliant. Okay, this is equation 2. Similarly, if you're asked to make I the subject of formula, which is not important in this concept, I'm concentrating on arrow, which is what you have there. But when we talk about inductive, a purely inductive circuit, this is where we'll be introducing what we call the capacitive inductive reactance. X stands for what we call reactance. When you see X, it represents reactance. This reactance is also measured in ohms, all right? But when you see X subscript L, this stands for what we call inductive reactance. Some people call it inductance. X subscript L is what we call inductive reactance. And we are interested in the formulas. Remember, what I'm interested in is formula, because without this formula, when I drop questions, you can't be able to solve anything. This is why I'm more concerned. We're about 23 on this live and 14 likes. Can you hit the like buttons, please? Give us a thumbs up. Okay, somebody said a bulb is 1000 ohms resistance. Okay, where does the current flow? Does it, is it straight or zigzag? All of that. Not watts. Okay, I think I can't flow with the comments. Maybe you guys are responding to the previous comment from some of your colleagues. That's completely fine. Okay, so now the unit for this is also ohms, whether it is inductive reactance, whether it is capacity. At the fact that we are mentioning this inductance, which has the unit ohms, then the unit for this is also ohms. But the formula is what we are concerned about. What is the formula for this particular one, inductive reactance? The formula for this is quite very, very simple. Have you heard of omega? Omega, what is the meaning of omega? Have you seen this symbol before in physics? Omega, L, remember I told you L stands for inductor. L is for inductor. That's the symbol for inductor. So when you have X subscript L is inductive reactance, then what about omega L? Omega L is the formula for this particular one. The formula for this inductive reactance is omega L. If you further want to expatiate this, you know that since omega is equal to 2 pi f, 2 pi f, f here is representing the frequency, and then pi, it has a constant. It's a constant which is 22/7. You can have pi in degrees, you can as well have pi in radians. Okay, so in this case, if you plug this into this particular one, let's say this is equation 3 and this is equation 4. If you plug equation 4 into equation 3, meaning that wherever you see this omega, in this case, you replace it with 2 pi f. Does that make sense? Okay, so X subscript L will be equal to 2 pi f L when that multiplies by L. Take this formula so seriously. Store this formula in your book right now. It's going to be helpful. Make sure to share this live so that your friends and colleagues will join us, because we have a lot to solve. I'm still dropping formulas. The more you like, the more people join. The more you share the live, the more you drop your comment. Please hit the subscribe button. That's very important, so that next time you get notification when we are live. Okay, we are done with this. We've covered the first one. We've done the first one, and we've also done the second one. The third one is capacitor. Who can tell us what capacitor is? I need just 3 things about capacitor. Who can tell us the meaning of capacitor, the unit for capacitor? The meaning of capacitor, the meaning of capacitor, the unit of capacitor, and what capacitor does in a circuit. What is the function of a capacitor in a circuit? So while you're doing that, let's talk about C is for capacitor. And you know we have factors affecting the capacitance of a capacitor. Some people call it capacitance, capacitor. We have different, but the formula is also there. But what we are interested in is to know that this C is representing capacitor. And then when we have X subscript C, which is our major concern as regard what we want to do, this is for capacitive circuit. Capacitive circuit. Capacitive inductance, we are talking about this reactance, capacitive reactance rather. Capacitive reactance. We've talked about inductive reactance. This is capacitive reactance. All right. Keep in mind, when you talk about these 2 cases, RLC circuit, this one we've talked about this, that the current and the voltage are in phase. In these 2 cases, one is either the current is leading the voltage or the voltage is leading the current. In one of the case, like capacitive circuit, the current leads the voltage by 90 degrees, whereas the voltage lags the current by 90 degrees. The inductive circuit, the voltage leads the current by 90 degrees, whereas the current lags the voltage by 90 degrees. So we're also going to be calculating for the phase angle and as the case may be. So, but let's talk about the formula for this. Okay, somebody said, what language are you people typing? Which one is Lalu Sawa? Is it the unit for capacitor? What dialect is that? But that's okay. So what we're gonna do here is to drop the formula for this. X subscript C, somebody just said 1 all over 2 pi FC. That sounds correct. Let's take it from this point. Look at, please pay attention to the answer dropped by Manoj. I'm sorry if I did not pronounce the name correctly. Okay, so in this case, we have this S subscript C, which is a capacitive reactance, to be 1 over omega C, right? 1 over omega C is the formula for this. We've already stressed or emphasized on this omega, which is angular frequency, to be equal to 2 pi f. So if you plug this into this particular equation, into this particular one, you have X subscript C equal to 1 all over 2 pi f then C. You can see that correspond with the answer Manoj has also dropped. That is very important. Some of you are asking about quality factor, you're asking about power factor, we are asking about pure. We are taking these things bit by bit. Yes, you have knowledge about it. That is brilliant and wonderful, and I appreciate you for that. We're going to take it bit by bit so that we carry everyone along. Is that okay? Is that okay? We are going to talk about the condition where we also have resonant frequency. In resonant frequency, what happened is the capacitive circuit equal to the inductive circuit, or is the capacitive reactance equal to the inductive reactance? And if that happens, how do we get the resonant frequency? I can also derive that and all of those things. Let's take it bit by bit so that everyone would be carried along. Okay, so let's move further to talk about, we've considered this 3rd case, which is C. We want to look at this one. We've talked about this case. Now let's move on to RL circuit. RL, when we talk about that RL, that is resistor and inductor. Then we are talking about impedance. You can say that impedance is the opposition to the flow of current. It's also in ohms. You can say impedance is a measure of the opposition offered to the flow of an RL, RLC, and RLC circuits. So for that case, for RL circuit, I'm going to introduce the formula for the impedance in RL circuit. For the third, fifth case, we're going to introduce the formula for the impedance in RLC circuit. I'm seeing a lot of comments here. I hope you guys are flowing. All students are, I don't know what that in the you are. I am good in electronics. Funny is working IT as coder. What coder? Like a programmer, do you mean? Okay, so no, please, you guys should not be doing that. Just pay attention to the class. You don't need to do that, please. Let's focus on the class so that we can flow. All right, moving forward, let's talk about this RL circuit. And I said that whenever you're talking about this RL circuit, we are going to be covering the formula for impedance for these different cases. Is that okay? So the impedance, the symbol for impedance is Z. Z stands for impedance. And please make sure to write the unit. The unit for impedance is also ohms. So we're going to consider impedance in RL circuits. And the formula is quite simple. Remember that we have impedance Z ordinarily from Ohm's law. We can still derive impedance as V over I, which is also measured in ohms. Keep in mind, because this is going to be useful when we want to solve problem. But the one I want to drop right now is the formula for the impedance. Because of time limitation, I would have shown you how that is derived. All right, I would have shown you the derivation of the impedance in RL circuit, particularly also RLC and RLC circuit. Okay, so in this case, when we have Z, which is for impedance, equal to, is going to be the square root of R squared plus X subscript L. Remember, we are talking about inductor. So that means we're going to consider the capacitive inductor, which is the inductive reactance, which is this one, squared also. And this, you get it by time you use the Pythagoras theorem. You'll be able to derive this. It's simple. It's as simple as ABC. But in your exams, you'll be more interested in the formula instead of the derivation. So in this case, we want to see also the formula for RLC circuit, because we want to move straight to the calculation part of it. For RLC circuit, which is, I think if you want to sketch the circuit diagram, it's also simple. You just have the symbol for resistor like this connected in series to that of the capacitor, and then you just have the AC main source. You just have the AC main source like this, and you want to also consider the voltage across the inductor. If here is arrow for resistor and here is for capacitor, you can have Hi guys, can you hear me? Please let me know if you can hear me right now. If you can hear me, please let me know in the comment section. Okay. Okay, I think I see people saying yes. Okay, that's okay. So this is the this is the AC main source, and then this is the voltage across the frequency and also the frequency. And then all the parameters here is something you're familiar with that we've mentioned already. Okay, so let's see the impedance in this particular RLC circuit. It's almost the same thing with this, but the difference is that you're going to replace with this inductive reactance with capacitive reactance. So when you have R squared plus here, you would have it to be XC squared. See how simple that is. If you're preparing for JAM exams, you need to take this seriously. Okay, I'm streamlining the class to help those preparing for exams like JAM and WAEC. All right, so even if you're preparing for GCSE and the rest of that, this is also important. The last formula I want to introduce at the moment, we also would look at phase angle for LC circuit, which is the same thing as RL circuit, RLC circuit. I'd like to also tell us about the phase angle, but that will come later after I would have started off with the calculation aspect of this. So for RLC circuit, when you see CCT is a short form for circuit. All right. This one said, please, I need your WhatsApp number. I want to join the JAM class. Thanks. If I don't know if it is YouTube only that you're following me. If you're following me on Facebook and Instagram, TikTok, I think my number are on those platform, my bio. Okay, for the formula for impedance in RLC circuit, it's also going to be the square root of R squared plus XL minus X subscript C all squared. Please make sure to take these formulas down. They are going to be very, very helpful. They are going to be very, very helpful. Oh, can you hear me right now? Someone said I should be a bit louder. Okay, so if you can hear me, then let's proceed. Let me also introduce the phase angle for LRO series circuits and also the formula for phase angle in RLC series circuits. Phase angle in RL circuit series or RL series. This one is very simple. Just say tan theta equal to V subscript L all over V subscript R. That's the formula. It's as simple as that. And of course, you know that from Ohm's law, tan theta is equal to, this one is something as IXL. Remember that Ohm's law V is equal to I R. Since we are talking about inductor now, since it's subscript L, instead of using arrow, we use that reactance, inductive reactance. That's why we are substituting this one for this one. Does that make sense? This is for I. Does that make sense? Did you get that? Let me know if you got the point. Okay, this is what we are saying. We say that tan theta is equal to V subscript L all over V subscript R. But we know that V subscript L is equal to I XL. This is the formula. If you don't understand this, remember that Ohm's law of V is equal to I R. This one is talking about Ohm's law, the voltage across the resistor. But for the voltage across inductor, we can't use R again. Instead, we use inductive reactance, which is X subscript L. Even if I'm talking about capacitive, the voltage across the capacitor is going to be I X subscript C. It's also for it's only resistor that has this particular one. Capacitor has this. Do you not get that? So if that be the case, you can see that if tan theta is equal to VL over VR, then anywhere you see VL, you can easily replace it with IXL, then over, what's the next thing we need to do? I arrow, because you know that this one, like I just said, is I arrow. So this will mean that I and I will cancel out, leaving us with X subscript L all over arrow. This is the formula for the phase angle, the RL circuit you need to be familiar with. I just show you how that is derived. Okay, so the next one we're also going to look for is the phase angle in RLC series, and that will be tan theta equal to V subscript C all over V subscript R. Remember that the formula for V subscript C is I X subscript C. The one for V subscript R is I R. So if I and I cancel out, tan theta will be equal to S subscript C all over R. This is the formula for the phase angle in RLC circuit. I'll be dropping the last one, which is the phase angle in RLC circuit. Let me know if you're following, please, in the comment section. And if you're just joining your work, please hit the subscribe button, like this video. Hit the subscribe button, support us by liking the video. And okay, I can see people are liking. I can see that already. So the next one I want to do is the phase angle in RLC series. And to get this phase angle, you still have tan theta equal to V subscript L minus V subscript C all over V subscript R. So already you know the formula for these individual parameters. Remember that for this first one, it's going to be I X subscript L minus I X subscript C all over. This one will definitely be IR. Is that okay? So the next thing you want to do is to make sure that you collect this particular I that is the common term. If you factor out the I, you then have X subscript L minus S subscript C all over IR. So this and this will definitely cancel out. Therefore, the phase angle for this RLC series would be X subscript L minus S subscript C over R. Please note this. They are very, very important, and you definitely will need them to solve a whole lot of problems. I can give you up to 16 or up to 20. Okay, I think I've not talked about power. I don't know if I'll have to do that right now, or the average power consumed in AC circuit. I needed to give you the formula, even the formula for power supply in circuit or power absorbed in resistance or in the resistance of circuit, in the resistance of circuit. We need to be familiar with all of this. Anyways, depending on the nature of the question we're going to be working on, then that will help us know. If not, I intended to give us up to at least 30 or 27 formulas under this RLC circuit. Under this AC circuit, I intended to show us up to 30 questions or 30 formulas rather on this. But then we're going to be taking them one after the other. And for resonance frequency in RLC series, that is just the inverse of 2 pi square root of LC. But then let's solve problem. Let's solve 1 or 2 problems to demonstrate some of the things we're talking about. And then before we end the class, we talk about root mean square voltage, the formula for root mean square current, and then instantaneous current of circuits. We're also going to be looking at instantaneous, which is EMF, which is electromotive force of a circuit. We're going to be looking at a lot of things that will be useful for these exams you're preparing for. Let's see question 1. Let's start solving problems. Please, if you're just joining, you're welcome. Hit the subscribe button, turn on the notification bell so that when we come live next, you receive notification. And if you've not hit the like button, please consider to hit the like button right now. We just have 18 likes. If you just hit your own, it increases. So let's look at the first question. Please take it down, it's very important. The question would say that you should determine the inductive, this is a past question, inductive reactance. Please pay attention to this. I've given you a formula for this. You are to determine the inductive reactance when a 30 millihenry inductor with a negligible resistance is connected to a 1.3 times 10 to the power of. Please make sure you guys are with your calculator so that it makes everything quicker. Oscillator. It makes everything quicker so that you can be able to solve a lot of problem here. Maybe if you like, I could just give you pi to be equal to 3.142 approximately, so that you can use that to solve this problem. If you're just joining, you're welcome. Consider to hit the subscribe button, turn on the notification bell, and like this video. Can we solve this problem right now? The first thing I like to say to physics students whenever they want to solve physics problem is to ensure they always fetch out the parameters given in the equation. That will give you an edge to know the formula that connects those parameters. You just definitely will know what next to do. So in this particular question, we could just say that given that, if you read through the question, you notice that you have to determine the inductive reactance when a, hello, please let me know if you can hear me in the comment section. Okay, you guys can hear me? Okay, because of the poor reception today, I think I'm going to repeat this class. I would not wait till next week, Saturday. I'm going to repeat this class on Monday at 9 p.m. So I'm going to communicate this to you guys across the platform. Is that okay? Does that sound like a plan? I'm saying because of the poor reception this evening, is it okay if we reschedule this class for Monday? We don't have to wait till next week Saturday. Next week Saturday is going to be for mathematics, because we've done chemistry last week. This week we're doing physics. The reception is quite poor, so we want to substitute today's class for Monday 9 p.m. Then Saturday we then continue with mathematics. And the mathematics, if you want, could be uh, calculus, except otherwise we choose another topic of importance and then play around with it. So is Monday okay? Please let me know if that works for us. Can we converge here by Monday 9 p.m.? Like I see somebody say yes, Monday is fine. Monday is okay. Okay. If that be the case, then I want to sincerely appreciate you guys for joining us this evening. But Monday we just start off with the calculations. Somebody say, okay, sir, but before ending, can you tell us the name of the symbols and the SI units, please? Which of the symbol, please? Which of the symbol are you talking about as this? Is it the name of the symbols of the parameters you're talking about? The parameters in this particular equation, which this is millihenry, if that what you're talking about, and Henry is a unit for inductor. Yes, we're gonna do this class to resolve this question also, but this is the first question we want to work on. All the symbols we did not talk about symbols, except maybe you're just joining and I can't question clearly. The reception is quite poor. I may be explaining this one, it will break again. So this is what I'm suggesting. But if you say I should give you guys the necessary tools for you to get this fixed yourself, I can do that before leaving. Okay. Since you're looking for inductive reactance, then inductor L is given as 30 millihenry. Please convert this one from 30 millihenry to Henry. So you just will say, either you can have it as 30 times 10 to the power of negative 3 Henry, or you can have this one to be maybe 0.3. Confirm if it is 0.3 Henry. Is it the same thing?